We do a pretty good treatment of graphing linear inequalities in two variables in intermediate algebra. What we don't do in intermediate algebra is systems of linear inequalities in two variables and applications of systems of linear inequalities in two variables. So I want to look at that here. A linear equation in two variables in standard form can be written, well, in this form, ax plus by equals c. We've got a straight line in the plane. Even the vertical and horizontal variety can be written in an equation like this, so long as a and b are not both 0. The vertical lines, that's where b equals 0, and you just have x equals a constant. Horizontal lines, that's where a equals 0, and you just have y equals a constant. If the line is slanted, then you'll have both an x term and a y term. But every straight line in the plane can be written like this, standard form of a linear equation in two variables. So the graph of this might look something like that. That's assuming positive slope. It could be vertical, it could be horizontal, it could have negative slope, but that's, I guess because I'm right-handed, it's just the easiest line for me to draw. So that's what I'll draw. Now, if we pick up the equal sign and replace it with an inequality, if we replace it with something like that, or if we replace it by something like that, or if we replace it by something like that, or something like that, then we have ourselves a linear inequality in two variables. Now the difference between the graphs, I should probably consider the straight line, which is the graph of the equation, and the two strict inequalities on the far right. The graph of one of those on the far right is the set of points on one side of the line. If we draw a straight line in the plane, it divides the plane into, I guess technically 3 regions, counting the line itself. There's the points on the line, there's the points on one side of the line, called a half plane, and there's the set of points on the other side of the line, also called a half plane. We have to know a little bit more information about the signs of A, B, and C. But if we can figure out the signs of A, B, and C, exactly what they are and the combination that they occur in, one of those half planes is the graph of AX plus BY is greater than C. And the other half plane is the graph of AX plus BY is less than C. I actually have, and I wish I'd fired this up right before class. Hopefully it won't take more than a minute of our time for me to find it. I have a fairly decent GeoGebra worksheet that just kind of illustrates where the points in the plane that satisfy one linear inequality are, and where the points in the plane that satisfy another inequality are. So, nope, not that. Let's open, probably got it in my 1105 folder. Shouldn't be too hard to find. Linear inequalities. Oh, wow. Could it be that one, maybe? Or that one? Let's go with that one. That should do a good enough job. Let's see what we have here. Notice the system there, and I'll make that a little bit larger so you can see it. There we go. Look at the top equation there. Negative x plus y is less than or equal to 4. This straight line, pretty sure, is the graph of negative x plus y is less than or equal to 4. If you look at points on this side of the line right here, kind of below and to the right of that line, what the GeoGebra, the program, does basically is it takes the x coordinate of that point. Say, let's see if it'll snap. See, it snapped to the point 6a. it takes the x-coordinate of that point, 6, and the y-coordinate of that point, 8, and substitute them into the equation, negative 6 plus 8, and it comes up with 2. And then it asks the question, is that less than or equal to 4? And it is. 2 is less than or equal to 4. So that makes the equation true, and so it gives the point a blue color there, meaning it satisfies it. If we snap to any point over here, negative 12, that's point 12, 9, so negative 1 times 12 plus 9, that's negative 3. Is that less than or equal to 4? Well, yeah, negative 3 is less than or equal to 4, so that makes it true. Now, if we move to the other side of the line, then pretty sure it makes it false. Negative 6, that's the point 6, 12, so negative 6 plus 12 is 6. Is that less than or equal to 4? No. 6 is not less than or equal to 4. So I don't want to go below the blue line. Basically, we can look at this worksheet a little bit later when we talk about systems of linear equations where we have two or more at once. But if I turn the trace on, if we want to know what does a set of points in the plane that make the equation true look like, I just kind of move it around, and you see as long as we're on this side of the line, any of these points, these make the equation true. But as soon as I move to the other side of the line, it colors the point green if it makes the equation false. So just kind of do a lot of this and a little of that, and you can kind of see what the solution set would look like. It's the set of points on one side of the line or the other, and for us it's just a matter of figuring out which side of the line it is. We draw the straight line, and then we pick a point on one side of the line and ask ourselves, does this point make it true? And if it does, we've got our half plane, and we just shade everything on that side of the line. If the point makes it false, what do you think? It's the other side of the line. Got to be one side of the line or the other. We only have to check one point to figure that out. Now we want to make sure we don't check a point that's actually on the line itself, because we don't get any information. If it has the or equal to bar, then that ordered pair would make it true, and if it doesn't, it would make it false, but it doesn't tell us which side of the line to shade. So we've got to test a point that's not on the line in order to make it true. Now, the way we'll distinguish our lines, if we have the or equal to bar, basically the points on the line itself satisfy the inequality since they satisfy the equation. So we would we would draw a broken line and then shade everything on one half of the line. On the other hand, if it's a strict inequality, if it does not have the or equal to bar, we'll draw the line, whatever it is. We'll figure out which side of the line to shade, but we won't draw it like that, my bad. We will draw it as a broken line. And that's just to signify that the points on the line itself do not satisfy the inequality. If ax plus by equals c, then ax plus by is not greater than c and is not less than c. So we would draw a broken line and then shade everything on one side of the line or the other, whichever one it is, after we figure that out. So we'll begin these examples by drawing either a broken line or a solid line. In this case, because it is a strict inequality, would it be a broken line or a solid line? Broken line. 5x minus 7y equals 0. It's not greater than 0. So in this case, got to be a broken line. And a lot of times, I would recommend finding the x and y intercepts. I think it's a pretty fast way to sketch the graph with a straight line if the equation's given in standard form. But in this case, maybe not such a great idea, because the x-intercept is 0. And the y-intercept is also 0. And we plot the x-intercept, we plot the y-intercept, we have a total of 1 point because the graph passes through the origin. So we could plot the origin, but maybe an approach other than finding the x and y-intercepts. So we begin by graphing 5x minus 7y equals 0 as a broken line. More than one way to sketch the graph of a straight line. X and y intercepts really not the best way in this case. A couple of options. We could find a single point on the line. Maybe you'd want to put it in slope-intercept form. If we subtract 5x from both sides, we have 7y equals negative 5x. If we divide both sides by negative 7, we have y equals 5/7 x. So put in this form, it's probably pretty easy to find an additional point. If you imagine a plus 0 there, you know it's going to cross the y-axis. And technically, although I really don't know that textbooks make this distinction, technically I should probably put open circles instead of solid dots, because a solid dot would seem to indicate that it is a solution to the inequality, and technically it's just a boundary point, not a solution if it's on the line. And then for another point, we could use the slope. Seem like a reasonable idea. Use the slope, since m equals 5/7, the 5 would have us go 5 units up and 7 to the right. So if we go 5 units up and 7 to the right, that certainly takes us from the origin to the point 7,5. Right there. And we could go from the origin 5 units down and 7 to the left, and that would take us to negative 7, negative 5. And then connect the dots with a broken line. Or using the Alex grapher, and we'll look at that in a moment and see if it gives us the opportunity to distinguish between a broken line and a solid line. It ought to have that functionality. And then choose a test point. Usually, the origin works as a nice test point. It's real easy to substitute 0 for x and 0 for y and ask ourselves true or false. But if the origin's on the line, it doesn't give us any information about which side of the line to shade. So lots of choices. Anything above and to the left of the line or below and to the right of the line is good. What would you like to use as a test point?
1, 1.
I heard 1, 0, 1, 1. 1, I'm not sure if I heard 1, 1 or not. To me, that is above the line, but it's kind of close. 1, 0 might be a simple one to use. So let's go with 1, 0 for a test point. So if we substitute 1 for x and 0 for y, we want to classify this as true or false. What do you think? 5 is greater than 0. That's true. So our test point makes it true. Our test point is below and to the right of the line, so we should shade the half plane that lies below and to the right of the line. So as artfully as you can. Hopefully far more artfully than I can. Shade everything below and to the right of the line and indicate that is the solution set. Have you done these before? Somewhere? Okay. Reasonably familiar. Example 1. Let's look at example 2 and see what different thing it has to offer us. It's also in standard form, but it does not have 0 on the right-hand side. So using the x and y intercepts might be an effective way to sketch this graph. So begin by graphing the equation 2x plus 3y equals 6 as a broken line or solid line. Solid line in this case because of the presence of the or equal to bar. If 2x plus 3y equals 6, it's a point on the line and it satisfies the equation because it would be less than or equal to 6. So solid line, and I'm thinking x intercept, or since I want to plot a point, maybe I should think the intercept on the x-axis. I think so. It's going to be an actual ordered pair here. Let y equal 0. All the points on the x-axis have different x-coordinates. They all have a y-coordinate of 0, though. So substituting 0 for y will help us to find the x-coordinate that can be paired with 0 to make it true. So the x-coordinate of the point that's on the x-axis. I'm thinking x equals 3. So plot the point 3, 0. I'll go with the solid dot here because it's going to be a solid line that we're going to use to connect the dots. Y-intercept. Points on the y-axis have different y-coordinates, but they all have an x-coordinate of 0. Substitute 0 for x and find the value of y that can be paired with 0 to make the equation true. And it will give us the point on the graph on the y-axis. Thinking y equals 2. Nice numbers in this example. 0, 2. So we'll connect the dots with a straight line. It would appear to have a negative slope. We don't really need the slope in this example. Something like that. Solid line. In this case, the origin works nicely as the test point. You should feel free to use any point not on the line as a test point, but the origin is good here. Two times 0 plus 3 times 0 is less than or equal to 6. True or false? I'm thinking once again, this is true. 0 is less than or equal to 6. Honestly, probably I should just use strictly less than rather than less than or equal to. Because in the case where I get an equality, suppose I've gotten 6 is less than or equal to 6, it could be misleading. What that means is I've mistakenly chosen a point on the line itself as my test point. If I get 6 equal to 6 right there, and even though it makes the inequality true because of the or equal to bar, it's not really telling me which side of the line to shade because the point that I've chosen is on the line, whether I realize it or not. So it's got to make it strictly less than 6 in order to be able to say that is below. There's our test point. So below and to the left of the line. Something like that. Let's see, special case. The case where you have y is greater than something or x is or y is less than something is also kind of special like this. In the case where x equals a constant, we're dealing with a vertical line. In the case where y is equal to a constant, we're dealing with a horizontal line. So begin by graphing x equals -2 as a, what kind of line? Broken or solid? Broken line. And are we all comfortable with this point that x equals -2 is going to give us a vertical line? Just plot a bunch of points that all have x coordinates of -2, like -2, 0, and -2, 1, and -2, 2, and -2, 3, and -2, 4, and -2, -1, and -2, -2. Just plot as many points as you can that have an x coordinate of -2, and you realize, oh, it's the set of points that are exactly 2 units to the left of the y-axis. So connect them with a broken line. And you can use a test point here if you like, but I don't think it's absolutely necessary. In the case of a vertical line like this, where would we expect to find points that have x coordinates less than -2? To the left, in the negative direction. So to the left, don't really think a test point is necessary. You could use the origin as a test point. 0 is less than -2, false. So don't shade the half plane that has the origin in it. Shade the other side of the line, like that. And if we wanted to, we could say example 3.5. 3.5, graph y is greater than or equal to 3. The set of points in the plane that have y coordinates greater than or equal to 3. How would you describe the set of points? On, or, let's see, so on the horizontal line, or where? So there's the horizontal line. y equals 3, which side of the line should we shade? Yes. Points with y coordinates of 4, 5, 6, 7, 8, 9, 10. So it's going to be above this line. So it's going to look like this. There we go. So that's another special case that probably should have been included in the notes, and we threw it in there. Y is greater than or equal to 3. And then the system. Example 4. We talked about systems of linear equations, a solution to a single linear equation is an ordered pair that satisfies that equation. A solution to a system of linear equations is an ordered pair that satisfies every equation in the system. Here, a solution to a system of linear inequalities is an ordered pair that satisfies both of these inequalities. So what we want is to look at the top one and figure out what half plane we would need for that, and look at the bottom linear inequality and figure out what half plane we would need for that. And it would be the region that they have in common, where they overlap, where they intersect. It's got to be in both half planes. So in general, the solution set, if we had something that looked like that, and then another one that looked like that, what we would want to do is redraw it. Let's see, like that, and shade only the region that they had in common, the cross-hatched region, if we're using straight lines to shade them. So we'll look at this example and see what these half planes look like. X plus y is less than or equal to 5, so begin by graphing x plus y equals 5 as a solid line. What's the x-intercept? It is 5. So we plot the point 5, 0. What's the y-intercept? Also 5. 0 plus 5 equals 0. So we plot the point 0, 5. And connect those dots with a solid line. While we're at it, let's go ahead and shade. Shade the half plane. Now, just a word of, not really caution, but just to keep this problem as real as possible, you'd want to do two things when graphing a linear inequality, or one of two things. Either have a good eraser, basically shade each half plane, and then erase everything that didn't get included in the actual solution region. Or if you want to use pen, or you just don't like to erase, be prepared to graph the thing twice. Graph it once, shade both half planes, and figure out, okay, this is where they overlap, this is where they intersect, and then graph it again, but when you graph it a second time, only shade the region where they intersect. Because if you graph it, say you put it on a test, and there's some parts that got shaded twice, and there's some parts that got shaded once, I'm not really going to know what you mean for the solution set to be. So the solution set, your final answer, should just, the only thing that should be shaded at all is what's part of the solution region. So either erase everything that just got shaded once, or graph the whole thing again, and I might do both in this case if necessary. So test point, let's go ahead and figure out, let's do the first one maybe in blue. Test point, we can use the origin. 0 plus 0 is less than or equal to 5. True or false? 0 is less than or equal to 5. I'm thinking true. So it's true. So we'll shade everything below and to the left, because that's where the origin is relative to this line. Then graph x minus y equals 6 as a solid line. Again, x and y intercepts, I think, are pretty easy to find. What is the x-intercept? It's 6. And I guess that's not the point. 5, 0. There would be 5, 0 there. 6, 0 there. And the y-intercept? Negative 6. 0 minus negative 6 is 0 plus 6, which is 6. So plot the point. Excuse me. 0, negative 6. Connect the dots with a solid line. Now, I believe on the test there's a reference to what's called the vertex of the system. It refers to the point where the two lines intersect, so I'll go ahead and label that. The vertex. And you can find the coordinates of this point by solving the system of equations. X plus y equals 5, x minus y equals 6. If you add them together, you get 2x equals 11. So I'm thinking the x-coordinate of that point is 5.5. And 5.5 plus negative 0.5 is 5. So I'm thinking the y-coordinate is negative 0.5. Just replace the inequalities with equal signs. You could use the elimination method. It's pretty easy to come up with the point where those two lines intersect. So 5.5, negative 0.5. And then pick a test point. Let's go with red for the test point here. Also the origin. 0 minus 0. That's less than or equal to 6. True or false? That's also true. 0 is less than or equal to 6. So we shade everything as far as this line is concerned. The origin is above and to the left of this line. So we shade everything above and to the left of this line. There we go. And then we look to see what portion of the plane got shaded both times. And it's kind of that, I suppose it just about is a quadrant because these lines intersect at a right angle. It's kind of a tilted quadrant. But it's to the left there. You can see what's going on. So I should do one of two things. Either I should go over here and basically redraw it, carefully labeling every aspect of it. Something like that, and something like that, indicating the point, 5.5, negative 0.5, and then just shading the actual region, or carefully erasing. Easier to erase the digital straight lines than actual straight lines. Carefully erasing everything that does not belong in the final answer. Okay, so you don't want anything shaded at all that's not part of the final answer. So this is the way I would want it to look, either one of these ways on the test. Let's try a couple of these with Alex. Have you graphed any of these with Alex yet? Is it pretty straightforward, clear how to do it? Just for my own benefit, then let me see if I can figure this out. And maybe it's also for somebody else's benefit. Let's hope so. It's not all just about me. Hopefully it's helpful. So Tuesday, Thursday, 8 o'clock. And student view. All right. I don't want to start with this. I'm going to click on review. I do want to do this because I don't have one like this in the notes. I don't know if you thought this was an easy problem or hard problem, but don't have one just like that in the notes. So I'll back it up. Maybe look at one of these in maybe one in slope-intercept form. I didn't have one like that in the notes either, although I think this is a little bit easier than the ones in the notes. Graph the inequality y is greater than negative 5x minus 4. If it's in slope-intercept form, we can plot a point. Let's see, plot a point, the y-intercept, so 0, negative 4. That's a point on the graph. And then use the idea of slope. Can we actually go, let's see, down 5 units and then to the right? I believe so. So plot another point. If we go 5 units down from there and 1 to the right, that would be 1, negative 9. That should also be a point on the graph. Now, it's going to be a broken line. How do I tell Alex I want it to graph a broken line?
Use that one right under the pencil.
Under the pencil, it's this one. So maybe I should graph it first and then click on that. So ruler next. Click a point, click another point, pencil. We got the line. Then
You have to click on the line.
Click on the line. Oh, there we go. Click on the line. And now can I toggle? Or do I have to click on the line again? Okay. So click on the solid to broken toggle switch and then click on the line. And then, I didn't mention this because it can be confusing and sometimes misleading if the equation of the line is given in standard form. Sorry, equation of the inequality. That's not an actual thing. The inequality itself. The inequality itself, if that's given in standard form, it can be misleading. But if it's in slope-intercept form, you can actually trust the direction the inequality symbol is pointing. And if it is a greater than, it actually is above the line without having to choose a test point. If it's a less than or equal to, it actually is below the line. Now, in the case of a standard form expressed inequality, you can't trust that because if the y has a negative coefficient, the process of putting it into slope-intercept form would require you to multiply or divide both sides by a negative number, and it'll flip it. So what should we say? If the coefficient is y, you can trust the direction the inequality symbol is pointing. If the coefficient of y is positive, but if it's negative, you can't. That's kind of complicated. I'd rather just use a test point. But if it's in slope-intercept form, we can trust it. We want to shade everything above the line because it's a greater than. If we wanted to use the origin as a test point, 0 is greater than 0 minus 4. 0 is greater than negative 4. That is true. And the origin is in the shaded region. So the test point confirms it, but in this case we can trust that. Looks like it's finished. Click on next. And it's good. All right. System of two linear inequalities. Graph the solution to the following system of inequalities. So this is nice. They're both in slope-intercept form, so we shouldn't be stressed out too terribly much. Let's see if I can get this right. So I'll graph the first one by plotting 0, 3. That's the y-intercept of the top inequality. And then using the idea of slope. Slope is -2, so 2 down and 1 to the right. So from 0, 3, that would be 1, 1. Would that take us to 1, 1? If we go 2 units downward and 1 to the right. 2 points on a line with a slope of -2. Next, ruler. Next, pencil. I go far enough up there, yes. Hopefully. Probably too low. I don't know. Finish it there. And was that broken or solid? That one is solid. Are we going to shade above or below this line? Above. We can trust the direction the equality symbol is pointing because it's in slope-intercept form. So we'll shade above this line. I wonder if I should have done that. I'm thinking maybe not. I'm thinking, I wonder if it'll let me undo it. Will it let me undo it? With the eraser? Ah, good. Yeah, maybe that wasn't a good idea. I'm thinking probably I should graph both of these. Now I did need to make a mental note. It's actually above and to the right of the line. What I should do is graph the other one and then only shade what belongs to the solution set of both. So let's graph y is less than 3x plus 7, or graph the broken equation. So how about 0, 7? And the slope of +3, we could go 3 up and 1 to the right, like that. And then the ruler, and then the pencil, and what's the deal? There we go. And then make it broken, because y is strictly less than 3x plus 7. Well, that's curious. I wonder if I messed that up.
No, it's okay.
It'll be okay with it? All right, what side of the broken line? We thinking to the right, below and to the right of the broken line, because of the less than, and above the solid line. So where is that going to be? Right here. This is below and to the right of the broken line, above and to the right of the broken line. Darn. Below and to the right of the broken line, above and to the right of the solid line. And so let's shade just that region. I'm thinking that's what it wants there. We'll see. I'm worried that this is kind of messy down here, but let's click next. Didn't like it. I wonder what about it didn't like. What do you think? Let's erase this line and let's redo it with those 2 points and the ruler and the pencil again, and make it broken. Maybe. I'm worried it may still not like it. Greater than or equal to -2x plus 3, that looks good. Less than 3x plus 7, that seems okay. Very good. All right. Yeah, it was messed up. I don't know. I guess I had gotten off the main line and it was a piece of some other line. It's curious though. It really shouldn't matter at all what's going on down to the left. Because in general, all that really matters is that we have the region graphed correctly. But it's a technical glitch, and that's okay. Let's look at this application. .5 solving word problem involving a system of linear inequalities. That one should probably graph over here and then come back and see if we can make it work. A gardener will use up to. Up to. Does that mean less than or equal to? Up to? Less than or equal to? Less than or equal to 240 square feet for planting flowers and vegetables. She wants the area used for vegetables to be at least 4 times the area used for flowers. Let X denote the area in square feet used for flowers. Let Y denote the area in square feet used for vegetables. And shade the region corresponding to all values of X and Y that satisfy these requirements. Now, I'm thinking maybe there are 4 linear inequalities that we're going to have to use, and I'm wondering if Alex is going to interpret it this way. I'm thinking that the area used for flowers plus the area used for vegetables should be less than or equal to 240. Total amount of area to be used, less than or equal to 240. But whatever she uses, she might not use all 240. Whatever she uses, she wants the area used for vegetables to be at least 4 times the area used for flowers. X denotes the area used for flowers. So the area for vegetables should be at least or greater than or equal to 4 times what she uses for flowers. So I think these 2 for sure, but also 2 more that are kind of implicit. I think the total area used for flowers should not be negative. That makes sense. We don't want a negative flower area in our garden. So I think that should be greater than or equal to 0. And I think the total area used for vegetables should also not be negative. I think that should be greater than or equal to 0. And we could do it without the X is greater than or equal to 0, Y is greater than or equal to 0, but anything in the second quadrant, third quadrant, or fourth quadrant would include either negative flower area or negative vegetable area, and really should be excluded. We're really looking for a subset of the first quadrant here. So hopefully Alex will interpret it like that. X plus Y is less than or equal to 240, so considering a scale here, probably we want to go 100, 200, and then somewhere up there we're going to have 240. Let X denote the flower area, and then Y is going to denote the vegetable area. And for that, let's say 100, 200, and 240. I'm thinking X and Y intercepts here. Suppose, I mean, we've got both constraints and we have to satisfy them, but if we're just looking at the top constraint, X plus Y is less than or equal to 240. If X equals 0, then, oops, that's up here. If X equals 0, then she could go up to 240 square feet of vegetables. And if Y equals 0, she could go up to 240 square feet of flowers. The other constraint is going to prohibit both of those, but let's connect the dots with the, I think all these are solid lines. Like so. Y is greater than or equal to 4x. That goes through the origin. If she decides, let's let the area for flowers be 0, then she's good so long as y is greater than, the area for vegetables is greater than or equal to 0. So 0, 0 be a possibility. And then that's a little bit on the tricky side. I'm thinking I might need to know the point where those two lines intersect to sketch a decent graph. So how about this? X plus y. So I need really the vertex of that, at least that particular vertex of the system. X plus y equals 240. How about negative 4x plus y equals 0? I was thinking about using that's probably a mistake, maybe the substitution method would be better since we've already got y equals 4x. So substitute 4x for y. X plus 4x equals 240. 5x equals 240. X equals 48. I think 48. And if y is 4 times 48, that's going to be 192 perhaps. So let's plot the point 48, 192. Has anyone completed this problem successfully? Yeah, this is a lot going on here. All right, so connect these dots with a solid line. And then x is greater than or equal to 0 means it's going to be well above the to the right of the y-axis. Y is greater than or equal to 0 means it's going to be above the x-axis. So we just want to make sure we stay in the first quadrant. What side of the y equals 4x line are we going to shade? Below, right? Below that, and also below this one. So I'm thinking it's going to look like this. I'm thinking she needs to pick a point somewhere in that shaded region. And if she does, the total area will be less than or equal to 240 square feet. And the area of the vegetables will be at least 4 times as great as the area for the flowers. That's not right.
No.
It's the other side of y is greater than or equal to 4x. It's this right here. Yeah, y is greater than or equal to 4x, and that would indicate above that line. So she's more limited. Yeah, if she's over here, then the area of the flowers could potentially be greater, or at least more than a fourth of the vegetables. So it's just right in there. That's where it's going to be. So let's see if we can take that. I want to keep in mind the point 48, 192. I think that's going to be an important point to plot, and then some other points. I think we can sketch this graph. So it's given us a good viewing window for doing this. So plot the point 0, 240. and plot the point 240, 0. And connect the dots. See with the ruler. Pencil. And solid line. So plot the point 48, 192. And the origin. Oh, that's got to be more painful to watch than it is actually to do this. Let's hope it's there. All right. I have to believe it wants me to graph the x-axis and the y-axis also. You think it does? About to find out. The origin, the origin's already there. The point 240 is already there. 240 is already there, so never mind. I don't want to plot a point. Let's just go with the ruler again. This one, and this one. And this really, I shouldn't even need that other line. So what? It's not even going to let me graph the x. Okay, so it will. I really don't need the other one, based on where our solution set was, but I don't suppose it'll hurt. It might hurt terribly. I don't know. Nope, didn't need that. Just the ruler. Click a point, draw the line, and shade that region. Is it going to like it? No way it likes this. No way. Let's find out. Ooh, no. What if I don't want to try again? What if I just want to find out what Alex says is the correct answer? What do I click next? Explain. All right.
No, you have to do it 15 more times.
15 more. So I have to try it again before I click explain, or can I go and click explain?
It's just adds more problems.
All right. So x plus y is less than or equal to 240. We did that. Y is greater than or equal to 4x. We did that. Aha! X is greater than or equal to 0. Y is greater than or equal to 0. Did that. Graphing the solution gives this answer. That's pretty much exactly what we did.
That'll happen sometimes.
No, we could have graphed the above region without drawing the line y equals 0. We noted that as well. So this is usually it'll say this is the correct answer. You answered this, and they're like identical. I think they were identical. I should have captured it before I did that, but that's pretty much what we did. What do you suppose I did or didn't do that it didn't like? Any theories?
Sometimes it just doesn't like it.
I like it after you do like acting exercise. We do a lot.
See, Wiz. Let's.
An assessment. I had 2 in the last 2 weeks.
Oh my goodness! All right, let's try this problem with Susan and see if we can see if we get this. We probably do this within the time allotted. Susan does a weekly exercise program consisting of cardiovascular work and weight training. Each week she exercises for at least 5 hours. All right. she spends at most 12 hours on weight training. This is going to be different. She spends at most 3 hours doing cardiovascular work. Let X denote the time in hours that Susan spends doing cardiovascular work, and let Y denote the time in hours she spends on weight training. Shade the region corresponding to all values of X and Y that satisfy these requirements. Whoa. So X is the time and hours Susan spends doing cardiovascular work, and at most means less than or equal to, right? At most, no more than, less than or equal to. So X is less than or equal to 3. At most 3 hours doing cardiovascular work. At most 12 hours on weight training. So weight training, less than or equal to 12. But combined, X plus Y is less than or equal, at least 5, so is greater than or equal to 5. Now, I suppose it's possible that we could have negative values if we don't insist on greater than or equal to 0 and Y greater than or equal to 0 as well. I think it's unlikely with that X plus Y is greater than or equal to 5, but possible. So we want to include those as well. Any other inequalities that we need? Let's do it. Let's do a rough sketch. These are all fairly simple to sketch. Let's go as high as Y equals 12. So let's say, 5, 10, 15. So 12 would be about right there. So there's the horizontal line. Y equals 12. And we'd shade everything below that eventually. X is less than or equal to 3. So on the same scale, if that's 5, then 3 would be about right there. So there's the vertical line, X equals 3. And it's got to be to the left of that. X plus Y is greater than or equal to 5. X plus Y equals 5 looks like that. Maybe just leave it like that, or just a little bit more. X plus Y equals 5. So it's going to be above and to the right of this line. Y is greater than or equal to 0 is just the x-axis, and I don't think we even need to sketch the x-axis on here. It's going to be to the left of X equals 3. It's going to be below Y is less than or equal to, or Y is equal to 12, so below that. So I think it's the region in here. Is that common to all these inequalities? Does that satisfy all of them? I think so. I think it's the region in there. If she picks a point in there, let X and Y coordinate, let X represent the cardio and let Y represent the weight training, then all these inequalities will be satisfied. So somehow we got to convince Alex this is what we believe. All right. So let's go with Y equals 12. So we could go 0, 12, and any other point with a Y coordinate of 12, maybe 3, 12 would be good. Plot it. Ruler. And connect the dots. All right. We're going to need X plus Y equals 5. Let's go 0, 5. And 5, 0. Maybe I didn't click exactly on one of the points I needed to click on. I probably just messed it up right there. But there's that. What other point? 3-0. Click on this point and pencil. And the y-axis. So ruler and ruler, pencil. Oops. What do you think?
Crush fingers.
Is it going to like it? I'm holding my breath. If it doesn't like it, I'm thinking redo x plus y equals 5, because I'm worried that I might have messed that up a little bit. It looks good, but next. All right, so it liked it. Well, there's hope. There is hope. We will include this nice, prettier picture than what I had there. As a reference. Okay, dare I ask how you feel about this? As long as the communication between yourself and Alex works out okay, I think it's a doable one. I could click on review one more time for that particular one, but I think it's going to. Let's see, what's it going to do? Oh, you think this will go okay, or would you care for me to look at this in the time that remains? We've got over 5 minutes left. We should look at Omar and his charity and just think this through and see if we can get this to work out. So we've got Omar and his intention to donate up to $500 to charity. And there are two different charities. There's the City Youth Fund and the Educational Growth Foundation. And the total, x plus y, needs to be less than or equal to $500. Also, he's decided, and this is resembling the gardening problem. Omar would like the amount donated to the City Youth Fund. That is x to be at least 4 times the amount donated to the Educational Growth Foundation, and that's y. So x needs to be greater than or equal to 4y. And other than the fact that he doesn't want them owing him money, the donations will be greater than or equal to 0 in both cases. These are the 4 inequalities, so I think we could sketch these pretty readily. X plus y is less than or equal to 500. We've got $500 there, and $500, 0 there. And connect the dots like that. We've got x is greater than or equal to 4y. If you wanted to, I don't know if you want to, but you could interchange the two sides and say 4y is less than or equal to x. Not dividing anything by negative, but when you interchange the two sides of the inequality, that also has the effect of reversing the direction it's pointing. And then divide both sides by 4. Y is less than or equal to 1/4 x. I would suggest figuring out the point where they intersect. To do that, you might want to use substitution. If you've got the equation x plus y equals 500, and you've got the equation x equals 4y, substitute 4y for x to get 4y plus y equals 500. 5y equals 500. That's nice. Y equals 100. And x equals 4 times 100. So x equals 400. So the point 400, 100, about right there somewhere. 400, 100 is a key point. And we want, when we're graphing y equals 1/4 x, y equals 1/4 x, we would connect those dots. That's the graph of y equals 1/4 x. Also a solid line. Everything is solid line. And we want the x. If you write it like this, y is less than or equal to 1/4 x. I'm thinking it's below that line. And it's certainly below the x plus y is less than or equal to $500 or equal to $500 line. So I believe it looks like this. What do you think?
And then just make sure to do the, in Alex, need to make sure to do the y or x-axis.
Yeah, we're going to have to graph the x-axis and those two lines. So here goes. Here goes. So we plot the point 0, 500, and plot the point. Come on, plot the point 500, 0, and connect those dots. Oh, indeed. There we go. And plot the point 0, 0. And plot the point 400, 100. Oops. Hope I didn't mess it up. Graph the x-axis. Just by clicking on that point and that point. And we don't have to graph the y-axis. And even Alex made a point of telling us we don't have to graph the y-axis. Just want to shade this region. Is it going to like it? I'm going to copy it just in case. It doesn't like it. And it liked it. Okay. So I think we've got the hang of this, or at least I do. I feel better about it than I did before.